Hi all. Previously, we built an image generation pipeline using open source stable diffusion model. Right? We utilized the dreamlike art model from the Hugging Face Hub, and we generated something like this. Right? We generated images using prompts. Now, based on this video, many of you requested that you want to improvise the results, you want to work on generating images that are more consistent, right? So for that, in this particular video, we are going to talk about the techniques utilizing which you can improvise the results, make them more consistent for using open source image generation pipeline, right? So this is the video that we developed earlier. I'll attach the link to this
We're
video
going to
as well
generate
in the
images using
description, as
text
well as the
prompts.
IU
We shall
command,
see the
and
various diffusion
technically what
pipelines for
we
tasks,
can
just text to
continue from
image,
there.
image to
And
image,
from there
text
we
to
come up
music,
with the improvement.
and the primary
Okay.
components of the
Now,
diffusion pipeline.
talking
So
about
we
the
shall also
improvement,
understand what the
there are two primary ways by which we can improvise the results for any image generation pipeline. This is a text to image generation pipeline. So for this text to image generation pipeline, there is primarily two techniques. The first is using the prompts. You can work on prompts and specify more consistent and more relevant prompts as input. The second technique is with respect to tuning the parameters that we supply to the model. Okay, so in now we shall talk about prompting later. Now let us first talk about some of the parameters that we can tune in order to make our images more consistent and more relevant. Okay, so for that we are going to talk about five different parameters: the negative prompt, image inference steps, num inference steps, width, height, and we can also generate multiple images for a particular prompt in order to have a range of image being generated. Okay, so I just this is the same notebook that we utilized earlier for our stable diffusion pipeline. And if you want to talk about, you can just watch our earlier video. I'll not go into the details of it again. I'll attach the link to that earlier video in the I link. Just follow along after that, after we generated the pipeline for that video. Okay, so now I just created a functionality utilizing the pipeline, the stable diffusion pipeline that we have, the prompt and the parameters. Now utilizing this, we will just generate images. We'll just generate images based on the prompt, specify the parameters that we have, and then plot those images on the screen. Okay, the very simple function just to create a wrapper. Now, our input that we are providing, the input prompt that we have is dreamlike, beautiful girl playing the festival of colors, draped in traditional Indian attire, throwing colors. Okay, so this is the prompt that we are specifying. And for the very first result, we are not specifying any additional parameters. All the other parameters will be the default as they are. Okay. So now when I call this generate function, essentially it runs for 50 inference steps. As you see here, this runs for 50 inference steps and it generates a very beautiful image of a girl in in a setting of a holy environment, the festival of colors, right? It is the season of festivities, the season of colors. So therefore we are trying to work around with the same context. Now, for this image, this image is fantastic. It looks beautiful, and this is generated quite well for using this particular prompt. Now, the parameter that we can specify in addition is the number of inference steps. We can increase the number of inference steps to improve the result that we are generating using this particular model. There will be differences in terms of the output that you are generating in multiple terms. Like for example, let me just run this again. Okay, I'll take this prompt. Meanwhile, if you're new to the channel, make sure to subscribe, stay on top of your generative AI learning, and never miss a video. Now you see, we pass the similar prompt, we reran the model, so we are getting something different this time, right? So this is one of the qualities of the model that you are going to, it gets more and more creative, right? Now, in order to conserve the creativity, there is another parameter that we will talk about in a while. Before that, let us look at the inference steps. Say now, if I want to run Here, for example, the inference steps is 50. Number of inference steps specifies the number of times you want the model to iterate over its results and produce more quality results. Okay, so I'm specifying the number of inference steps as 100 and I'm rerunning it. Let us look at the results. You see, the number of inference steps that we are running for is 100 here. Okay, so this is the first parameter that we can use in order to make our results more efficient. Let us observe what the results we are getting. Okay, you see, so the results have improvised. You see the clarity of image that you are getting here. You are getting much more details as compared to what you got earlier, right? Compare this image with the image that we have here. The clarity that you see, right? This is very much look-alike. This is very much realistic in a sense. So this, as you increase the number of inference steps, definitely your results will improve. Okay, so this is the first parameter. Now the second parameter you can modify is with respect to the height and width. This is basically the aspect ratio of the generated image. And why this is important, let me take you over to the documentation of the model that we are using. So the model that we are using is Dreamlike Art, Dreamlike Diffusion 1.0. So here if you see, they have mentioned that use slightly higher resolution for better results. 640 by 640, 512 cross 768, right? And they are saying non-square aspect ratios work better for some prompts. So, right? So this essentially depends on the way this and actual model was being trained. So since they have already specified to use an aspect ratio of 2 is to 3 or 9 is to 16, let us try and play around with the height and width. So by default, by default, the size of this image or the dimensionality here is 640 cross 640. Okay. Now I am specifying a width of 640 and taking a height of 1.5 times of 512. So, okay, I'm just giving some combination of the output or combination of the width and height that I want to specify, and I'm generating an image. So this is the image that I'm generating. You see the aspect ratio of this image has changed, and depending on the aspect ratio, depending on the model that we are using, you're going to get slightly better results, slightly improvised results. So this is the capability of specifying a certain aspect ratio for the model. Okay. So we talked about the inference steps, we talked about width and height. The third thing that we are going to talk about is a negative prompt. Negative prompts are very important aspect when you are generating images using text prompts. Negative prompts help the model to move away from certain terminologies, from certain keywords that you want the model to refrain from generating. For example, if I specify a negative prompt as inconsistent patches, so the model will try to keep its generated images far away from the region where it might generate an inconsistent patches. Okay, so here let me just run this and show you. I have specified a negative prompt as ugly, deformed, bad anatomy. It is just a simple string wherein you specify what are the things you don't want from a model. You can make it very much context specific. For example, if you don't want a forest setting, you can specify forest here. If you don't want a city setting, you can specify city here. Whatever you don't want within your model output, specify it to help the model give you more relevant and more contextual results. We are running it for 150 inference steps, and let us see what the result we are going to generate. While this is being generated, let us specify the number of images. While this did not do a very good job, let us just rerun it. Sometimes it might happen that the results generated are not satisfactory, so you might want to run it for multiple iterations. That is how you generate a very effective and a highly effective output. Okay, it takes some time and it takes little iterations. Okay, so the results from our earlier where we specified the negative prompt, ugly, deformed, bad anatomy. So we see there is no bad anatomy, we don't have any extra limbs, we don't see anything which is ugly, we don't see anything which is deformed. Okay, so the results that we are getting are very much consistent with the prompts that we are specifying, with the negative prompts that we are mentioning. So the results are going good. Okay. And certainly you will find the results that we generated in our earlier video for the first part of the stable diffusion video. We have much better results in that comparison. So just based on the request that I received from multiple people that they want to work with this model, they want to see more consistent, more better results. Therefore, I thought that I should put together this video to help you with the process. Okay. So you see, we have specified the number of images to generate per prompt, that is 2, and we are getting 2 images per prompt. So as you increase the number of images generated, usually the ideal number of images generated per prompt is 4. So it helps you choose between one of the best images being generated, right? Because the first image generated might not be actually what you are looking for, but if you have a some range of images, then you certainly will find something which is very much relevant. Okay, so this is what I wanted to show you and help you with. Hope you understand now how you can use the parameter tuning techniques, or you can just specify certain different kinds of parameters in order to make your results, the image generated results, very much effective and efficient. So we talked about the number of inference steps, we talked about negative prompt, height and width, and number of images per prompt. See you in the next lecture. Have a nice day. Bye bye. Jai Hind.